Let's talk about arrays in Java. This is chapter 8 in the Gaddis book. We're going to cover these things, basics of arrays, how to search them and manipulate them, and talking about parallel arrays. So very simply, an array is a special kind of variable that allows you to put more than one piece of data under the same variable name. So for example, if we had 3 employees and we wanted to record information about them, we would have to create a variable employee 1, employee 2, employee 3. We'd have to create 50 of those, or however many employees we had, we have to create one variable for each of those. That doesn't work. That's, you don't know how many employees there are. You don't know how much data you're going to want to keep until the program begins to execute. And so this just is very inefficient. So we can create a single variable here called employees, and we can give it a dimension. This says that in this case there are 50 employees, and so we typically, when we name an array, we're going to name it using a plural because each element in the array is going to be an employee, and the whole list of employees itself is going to be called employees. So in this case, we're declaring an array of strings. This would presumably be the employee name, and there would be 50 of them. Here's an example of us creating an array of sales amounts. This would be a decimal number with 7 of them in it. So maybe that's average sales per day or something like that. So an array is really just a special kind of variable that allows us to put more than one piece of data under the same name. And then we can access that using the indices of the array. This is what it looks like when you kind of draw it out. You have, so this whole row here would be one array. And in this case, it's called numbers. Okay, and so this whole variable is called numbers. It has 5 pieces of data in it. Refer to each of the elements in an array. We call them elements. That's each of the numbers inside that array. Now, all of the elements have to be the same type. In this case, they're all integers. So you can't have in Java, you cannot have a mixed array with different types. You can't have a single array with an integer in one and a double in another and a string in a third. That doesn't work in Java. That does work in some other languages, but in Java, all of the elements of an array have to be the same type. We also refer to these elements using the subscript notation. The first element is always going to be 0, and we have 0, 1, 2, 3, 4. So in this case, this is an array of length 5, and it has 5 elements starting at 0. So 0, 1, 2, 3, 4. That's 5 elements in that array. We can assign values to the individual elements using the subscript notation in square brackets. So in this case, when we assign to numbers at 0, we assign it 20. So now the array is now set at 20. When we create the array like this, in Java, the array is going to be initialized to its default data type, to the default value of the data type. So if you create an array of integers of 5, the initial value of each of these elements is going to be 0. And then here we can come in and set them to be whatever we want. Typically, we're going to use a for loop to do that because we're going to be reading that data from the user or from another location. This is what the array would look like after it's been filled. You can also initialize arrays using a string notation or list notation. This is pseudocode. So in Java, it would look similar, but it would have this list of elements would actually be in a list notation using curly braces, and we'll see that later. But you can initialize an array. So if you have an array of constants or commonly used elements like the days of the week, maybe you want to create an array to do that, and you want to initialize it being done there. Also, keep in mind that if you initialize an array of 7 here, this is a string of length called a string array called days of length 7, which means it has 7 elements in it. Those elements are numbered 0 through 6. So if you use days 7 right here, then you're going to get an error, and it's going to it's called off by 1 error. In some cases, the actual Java error is going to be something like an invalid index range or something like that. But just know that if you have an array of 7 elements, that's 0 to 6, and if you attempt to use an index that's less than 0 or greater than 6, then you're going to get an error at runtime. Most languages provide a special kind of for loop called the for each loop that you can use to iterate very quickly over the array, and we'll see this in Java. This can be very useful if you want to just quickly go through the array and do something with each element. The advantage of this is that you can In Java, it's very fast and easy to write, and it's easy to understand. It has less code involved than writing a traditional for loop. The downside is that when you're processing this, you don't know which element you're processing. So, in this case, we're going to process the elements 0, 1, 2, 3, 4. But inside the block of each iteration of the for loop, you don't know which index you're on. You don't know if you're processing 1, 2, 3, 4, or 5. So in that case, it's not useful in every case, but in many cases, it's very useful. You can also process this just using a traditional for loop, which we'll see here in a minute. So here's this is an example of searching an array. So in this case, we have an array of strings, and we're trying to find a search value in it. So we're using a while loop here with a while keep going type loop. They're using bound in this case. And we're making sure that we don't go past the index. So in this case, this while loop is going to run. It's going to look at each element in the array. If it equals the search value, then it's going to say, hey, I found it. And then you can return the index value or whatever you want to do. Maybe you're just trying to find out if the element is in the array. Maybe you're trying to find out which element it is. You can, or maybe you want to do some specific processing on it. Maybe you want to print it out, or you want to send it to a subroutine or another method of some kind. Whatever you're doing, you can then do that at this point. But this is a quick way to just iterate through each element of the array and process it. In this case, it's going to stop as soon as you find it. You might want to use a for loop here if there might be more than one value in the array that would match your search. Then you would use a for loop and you would look at all of the elements. The point here is that you can use a while loop or a for loop to iterate over the array and do something to each of the elements. Process it in some way, display it, send it to another method, transmit it over the internet, do summation on it, whatever you want to do, you can use a while loop or a for loop to iterate over that array and then do something with each of the elements. So we use commonly loops in Java to accumulate the sum and the average of an array. We've done that in this course. We're going to do that in assignments and examples later in this video. But very simple, arrays are great if you're keeping lists of things, lists of grades in the class, lists of inventory in a store, things like that. Arrays are the way that you're doing that. Here's an example. This is going to declare an array size. So we're declaring a constant named 5. We then declare an array of length 5. We could use a literal here 5. We could also just use the variable name, in this case a constant, but we could prompt the user for how many values do you want to enter. Then they are using the list notation to initialize the array. Then we're doing the total and the average. We then use a for loop, and we're just summing up each elements of the array. And then we use an average divided by size. We don't need to know the size. We don't have to keep track of the size here. You could use, in Java, you can use the array.length that will tell you how many elements are in the array. So in this case, once you create this array scores, if you ask for scores.length, that's going to be 5. So you know that that's the number of elements in the array. So it's in this case, they're using this constant, but you don't need that in Java because Java will keep track of how long the array is for you. Okay, here's an example where you want to pick out the highest and the lowest the highest and lowest in an array, highest and lowest values. Simply create a variable to hold the highest value. You then assign that, you initialize that value to be the first element because the highest, you have to initialize it to be something. 0 may not be, you don't know what's what the elements are. So 0 or a big negative or a big positive number might not be valid in the context of the array. So I always want to assign the value of element 0 to the highest, and then you just use a loop to step through that and compare if it's higher or lower, etc. So we'll see an example of this later. Here's an example of passing an array as an argument to a parameter, or to a method rather. So you can define it as a parameter here. So this is called get total, and it accepts an integer array here. In Java, you don't need to pass the array size because you can just get that by saying array.length. So you don't need this in Java, but in pseudocode, sometimes it's included. And so then you can just process the array. In this case, this is summing up the array You could do the same thing if you wanted to get the minimum or get the maximum, something like that. Okay, this is a example of how you would then call the method. So we've defined it here as get total. It has one parameter called of an integer array. And then here we would pass it just using the number. So it gets passed and received to a method just like any other variable. We can also create something called parallel arrays. And so often we're going to want to keep more than one piece of data about something. So maybe we have a list of people. We want to keep their name, maybe their birth date, and maybe a phone number. So we might create 3 arrays. We'll call them parallel because each element in the array is related to the corresponding elements in the parallel set. So in this case, if we have this is a set of 2 parallel arrays. One is name and one is address. And so the element 0 is the information for person 1. The element 1 is the information for person 2. So in this case, by declaring to ourselves that these arrays are parallel, we know that the names element 1 and the address element 1 refer to the same individual, that those two are related. This is common. It's not the only way of creating more complex data sets, but this is a useful way for doing that if you have very small, simple data sets. You can use these parallel arrays to do that. Again, we'll see an example of this later. Let's look at some specific Java implementations. Here's how you define an integer array. So you declare integer array. We've seen the array notation in our main. Remember, when we declare the public static void main and we give it a string array of arguments. This is the same thing. We're declaring an integer array using the array notation, the primitive data type int, the square brackets. This means this is a data type of integer array. It is not a data type of int. Int is the primitive data type of each element. This is the data type for integer array, which is not the same thing as an integer. Okay, the array is a different kind of variable. It's a different data type. It's not an integer. Each element in the array is an integer, but the array itself is a different data type called array of integer. So you have to use the new notation in Java. So in this case, we're declaring a variable named numbers. It's going to be of type array of integer. We're going to initialize it to a new integer array of 6. Okay, we have to use the new keyword here because arrays are objects like scanners or anything like that, and so we have to use the new to create an instance of that. Okay, we can also do that using a constant. In this case, size. We could also just prompt the user, how many integers do you have? And then we could use their response here. Okay. This declares a double array of size 200, so we can have an array of any of the data types. So any individual variable you can have an array of that same variable. So double and string, as we see, are defined here. Here's an example of us accessing the array elements. So you see we've defined an integer array called numbers. It has 3 elements in it. We can access those elements using numbers 0, 1, and 2. We're using the subscript notation with the square brackets. Keep in mind we're starting at 0 here. So an array of length 3 has elements 0, 1, and 2. There is no element 3. Element 3, if you try to reference element 3, you'd get a runtime error. This is the list notation for initializing an array. In this case, I say I want to create an integer array called days, and I want to put these values in it. This intrinsically creates an array. It then counts the number of things in this list. There's 12. These are the number of days in each month. And then it creates an array of length 12 and sets the first element to 31, to second to 28, et cetera. So this is element 0, element 1, element 2, et cetera. Okay. The length attribute is how you get the number of elements in the array. So once I've created the array of 25, then I can ask the array itself, how many elements do you have? Temperatures.length. Okay. So this will tell me, I can use this in a for loop. I can use this to just get information about the loop or about the array. So, but I don't have to keep track of what the initialization was. And it may be I got the length from the user, or maybe I looked up the number of entries in a file and that's the length. So it may not always, you don't always know when you write the program how many elements are going to be in the array. So you can use this length this built-in length property of the array to get that. It is worth noting here that the length is a property of the array and not a method in the array. So there's no parentheses here. So length, it's not length parentheses like you get with next line, from the scanner or things like that. So this is a little unique in using in an object, in that this is not a method of the array, it's a property of the array. And so it is, because it's unchangeable. And so so you don't need to use the parentheses to get that. Here's the example of using the length in a for loop. This is a typical Java iteration using a for loop. For integer I equals 0, so because all the elements start at 0, we'll go until I is less than, we'll go while I is less than the length of the array, and we'll increment by 1, and then we can iterate over the array one element at a time. When passing an array as an argument, you don't have to include the length because we can derive it from the array itself. So here's an example of receiving an array as a parameter. And then when you pass this, you just use the array as any other variable and as any other variable name in the argument for calling this method that you would in any other type of variable. Here's an example of the for each, the built-in notation. It's called for each, even though it still uses the same for, but the initialization of the for loop is different. So instead of using the 3-step initialization, we just say for each element in the array, do this. And so this works the same as the for loop that we saw here. This bit of code and this bit of code produce the same result. The only difference here is that in this, using the traditional for loop, I actually know what element I'm processing because it's in this variable I. So if I needed to know that, if I was on the 3rd or 4th or 5th element, I would know that using the traditional for loop. In the for each, I wouldn't know that. I don't know which element I'm processing inside each block. Okay, you can also sort arrays using the built-in arrays class. So just like we have built-in integer and double classes that we're using for parsing and other methods, there is an arrays wrapper class that we can sort. And we do this way. We create the array, we print it out. When we created it, it looks just like this, 529156, just the way we initialized it. We can then sort the array using arrays.sort, and we give it the name of the array. This is sorting in place. So this actually takes the array, int array, and it changes the order of the values in that array, which means that the array has been modified. You cannot get the original value back once you run the sort. So if you need to know if the array needs to be in a specific order, then you can't do this. So you cannot sort parallel arrays in this way, for example, because in a set of parallel arrays, you have to do the exact same thing to each element in the array because they're parallel. And so if you were to sort 2 parallel arrays, you would destroy their parallel nature because the elements would not be matched anymore. But you can sort any array, any primitive array using this array.sort. You can also sort more complex arrays and by using something called a comparator, where you can actually give it your own comparison method. So if you wanted to sort descending, or maybe you're sorting a more complex set of, you have different rules for sorting than just numeric order, you can do that. We don't have any examples of that, but just know that sorting of arrays is a very capable function within Java. There's lots of how to sort arrays using for loops and while loops and swap methods and things like that are commonly taught in computer science. I don't teach those because nobody ever writes those anymore. All array sorting has been solved. So nobody really writes sort routines by hand anymore. It's an interesting computer science problem, but it's not particularly useful. And so I don't do it. We're just going to use the built-in sort method. It's also notable that in some languages, there are built-in sum and average methods and things like that. There are not in Java, but in other languages there are. And frankly, if you have access to that, you should use them. But it's very easy to do, and we're going to do some examples in Java of that. Once you sort the array, you'll notice that it's just sorted ascending here. So this is the output once the array is sorted. But again, if you sort an array, know that you have permanently changed the value of those elements, and you cannot get it back to the original order. All right, we'll do some exercises in the subsequent video.